So for our waves project, we decided to do two different types of waves. We decided to do sound waves and tsunami waves. Tsunami waves and sound waves are both mechanical. The purpose of these experiments are to teach people why they are hearing the sounds they hear and for them to have a better understanding of tsunami waves can affect the shoreline.
First, we are going to demonstrate the tsunami wave. A tsunami is a series of large waves generated by an abrupt movement on the ocean floor that can result from an earthquake, an underwater landslide, a volcano eruption, or very rarely a meteorite strike. Most are caused by earthquakes or generated in a body of water by another
demonstration we decided to do for a tsunami wave was a tsunami in a pan, but first we are going to explain the characteristics of the tsunami wave itself. These characteristics include the wavelength, the amplitude, the run-up of the wave, and the wave velocity. Usually your everyday wind waves have a length that is about 100 meters, while tsunamis usually have a wavelength of 200 kilometers, and the wave travels over 800 kilometers an hour. So it's double a regular wavelength, going faster with a greater amplitude. When the tsunami approaches the coast and the shoreline, the wave is compressed and the velocity slows down to below 80 kilometers per hour. Then the wavelength shrinks to 20 kilometers and the amplitude grows larger, making the wave visible to people on the shore. If the tsunami still has a huge wavelength, it will take minutes to develop its full height. However, larger tsunami waves do not break but appear to be faster. The wave run-up is measured in meters above a reference sea level, and the first wave to hit the shore will most likely not have the highest run-up.
Now we're going to show you how to do this tsunami in a pan experiment. You will need an aluminum disposable pan, plastic wrap, sand, water, and a water source, and plastic gloves and mud.
And a knife and toy houses and paper and tape.
No. The first thing you need to do is cut a circular hole in the bottom of your pan and tape the plastic wrap underneath it. Okay. That's it. That's 2 centimeters.
Okay, Hayden, we need you to record about.
Yeah.
Okay, now we're going to crumple up pieces of paper and fill the pan like a third of the way. And then when you have your gloves on, your Ultra IC gloves, or whatever, you're going to take some mud, kind of crush it up, and then you're going to pile it over the paper. That worked. And you're going to make a slope. Goes downwards. Okay, and then you get your sand. And you stab it with your knife. And pour it all over the part where the slope meets the shore line. And then pat it down. And then we're going to get our toy houses and place them on the dirt mount that we made. And our little people that we made out of Legos. It's not going in there. Backwards, but it's whatever. Okay, then we're going to get our water source, and pour it in the little part that we made our hole. Are you recording? Mm-hmm. And then you're going to place your hand where you put the plastic, and you're just going to make
The fault slippage generates earthquakes when the release of energy causes the ground to shake. The energy is carried when energy is transferred through the vibration in the ocean floor. The amplitude of the tsunami is determined by the amount of seafloor that is displaced. The wavelength is the distance between the highest and lowest point of the wave. As you see, the wave slowly moves up the shore because my hand is demonstrating earthquake.
I don't know what I'm supposed to. Okay, this experiment demonstrates the tsunami wave because tsunamis are generated from the movement of the bottom of the ocean. And our hands are representing that sudden movement by placing our hand on the bottom of the pan and making an earthquake-like movement, causing the water to rise up.
There are no ways to stop a tsunami from happening. However, there are ways to prevent the damage. When building structures, people can use 2x6 lumber instead of 2x4. The shield helps prevent some of the damage. It does not always block, but it does not always block the wave. Planting mangroves and other plants can help prevent the complete force. Taller buildings are safer for tsunamis, but not during the earthquake.
Some basic facts about tsunamis include the following.
25 tsunamis have occurred within the last century, with many of them being on the Asia-Pacific region, particularly in Japan.
The 2004 Indian Ocean tsunami killed over 200,000 people with bodies lost in the sea.
The states at greatest risk for tsunamis are California, Oregon, Washington, Alaska, and Hawaii.
About 80% of tsunamis happen within the Pacific Ocean's Ring of Fire. Ring of Fire!
Pew, 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 pew. Here's some pictures. Look at my eyebrow.
Oh my god.
I did to do a sound wave, and a sound wave is a compression and rarefaction by which sound is propagated in an elastic medium such as air.
The sound wave carries energy because the air molecules causing a longitudinal wave to propagate until it hits our ears. Our ears take the vibration and send signals to our brain.
The materials needed for this experiment are 2 rubber cups, a thumbtack, and 12 feet of string. To start this, you will need to poke 1 hole in the bottom of each cup and stick the string through each hole, tying it on the inside of the cups. After you do this, when you speak in the cup, the other person should hear or feel the vibration of the string. This demonstrates a sound wave because sound is generated through the vibration of something, and when we talk into the cups, the string vibrates so you can hear the other person speaking into the cup. Sound wave characteristics are the frequency and the wavelength. The wavelength is the distance between analog points of 2 successive points. Speaking into the cups creates sound waves which are converted into vibrations at the bottom of the cup. The vibrations travel along the string and are converted back into sound waves at the other end so the other person can hear you. Sound travels through the air but travels better in solids such as the cup and the string, allowing you to hear sounds that might be too far away when traveling through the air.
Okay. These are some sound wave facts. Dogs can hear at a higher frequency than humans.
When traveling through water, sound moves around 4 times faster than moving through air.
The sound of thunder is caused by heated air surrounding lightning.
The sound of a whale song can travel a distance of 800 kilometers. Here's some pictures.